Okay, just take a look at this, the Pantheon in Rome. I mean, what a masterpiece of engineering, right? Its concrete dome is still the largest unreinforced dome in the entire world, and it was built almost 2,000 years ago. The Romans were absolute masters of logistics, architecture, and engineering. So here's the real head-scratcher. Why couldn't a civilization this brilliant invent something as world-changing as the steam engine? Well, the answer isn't about steel or mechanics. It's about a single revolutionary idea they were missing. An idea about, of all things, nothing.
So what was really holding them back? It definitely wasn't a lack of genius. No, it all came down to this deep philosophical resistance to an idea that we just take for granted today, the concept of nothing. You see, for the ancient Greeks, who basically laid the philosophical groundwork for Rome and the entire Western world, the void, it wasn't just empty space. They thought it was literally impossible. This one phrase, nature abhors a vacuum, pretty much sums up their entire worldview. For thinkers like Aristotle, numbers had to represent real, tangible things. You know, the length of a line, the area of a square, a pile of apples. So how could you possibly have a symbol that represents no thing? It was a total logical and metaphysical contradiction. If every number is a thing, then a number for no thing just couldn't exist. And this wasn't just some mathematical quirk. It was a threat to their whole understanding of an orderly, filled-up cosmos.
And this block in their thinking had these huge, real-world consequences. Sure, their geometry was brilliant, but their ability to do any kind of complex arithmetic or algebra was severely hamstrung. They could describe static shapes with incredible precision, but they just didn't have the tools to mathematically describe systems that change over time, which, is the very essence of physics and engineering. For over 1,000 years, this fear of the void meant the West stood still, mathematically speaking, while all the innovation was happening somewhere else.
And this right here just makes the problem perfectly clear. I mean, just imagine trying to divide 2024 by 44 using Roman numerals. Go ahead, try it. There's no algorithm, no long division. You can't do it on paper. You'd have to use an abacus, converting the symbols in your head, do the calculation, and then translate it all back. It's a total cognitive nightmare. A number system without a placeholder for an empty spot has a really hard ceiling on how complex it can get. It's great for carving dates on monuments, but you can't build an industrial revolution with it. So the journey to conquer the void, it didn't start with a number. Nope. It started thousands of miles away from Greece and Rome with something that was basically just a form of punctuation, a little mark to help avoid confusion. What's so fascinating is that great ideas almost never appear in a single flash of genius. The concept of zero was a slow burn. It's like this idea was on a multi-continental relay race. It starts as a simple mark in Babylon, then it becomes a true number in India, it gets refined and spread by Islamic scholars, and finally it has to fight for its life to get accepted in Europe. Every single step was absolutely essential. So let's be super clear about what this Babylonian symbol was and what it wasn't. Around 300 BCE, they needed a way to tell the difference between, say, 306 and 36. So they invented a placeholder, these two little slanted wedges to show an empty column. But that's all it was, a placeholder, a punctuation mark. You couldn't add it, you couldn't multiply with it. It was a symbol for absence, not a number with substance. A vital first step for sure, but it wasn't the revolution itself.
So where did the real breakthrough happen? Well, for that, we have to travel to ancient India, where a completely different philosophical outlook unlocked the true power of nothing. This is where the void goes from being a problem you avoid to a concept you actually embrace. You see, unlike the Greeks who feared the void, Indian philosophy, especially in Buddhist and Hindu thought, really explored this idea of shunyata, or emptiness. The void wasn't some horrifying vacuum, it was a state of pure potential. This cultural acceptance was the fertile ground that a mathematical revolution needed to grow. It allowed mathematicians to imagine zero not just as a lack of something, but as a quantity in its own right.
And then, in 628 CE, a mathematician named Brahmagupta comes along and does something truly profound. He writes down the rules. He formally defines zero as what you get when you subtract a number from itself. And then he laid out these simple, elegant laws for how it behaves. All of a sudden, zero wasn't just a placeholder anymore. It was a fully operational number. By formalizing these rules, Brahmagupta had just invented the foundation for all of modern algebra.
This powerful new math system, with its 10 digits, including zero, started traveling west. It was picked up and refined by brilliant scholars in the Islamic Golden Age, like Al-Khwarizmi in Baghdad. His work was so foundational that his name, Al-Khwarizmi, gave us the word algorithm, and the title of his book, Al-Jabr, gave us algebra. Both of those concepts are completely dependent on the power that zero provides.
But when this system finally got to Europe, man, it was met with some serious suspicion. Merchants in Florence actually banned it in 1299. Part of it was practical. They were worried it was too easy for someone to forge a 0 into a 6 or a 9 on a contract. But the resistance went deeper. The church saw the concept of a void, of absolute nothingness, as a heretical threat to the idea of a God who is present everywhere. The battle for 0 had officially begun. But in the end, utility won out. The power of this new system for trade, finance, and accounting was just undeniable. And once 0 was firmly established in European mathematics, it became the fuel for the single most significant intellectual explosion in human history, the scientific revolution. Okay, so how does it actually work? Well, it all starts with a property that sounds almost kind of childishly simple, right? 0 is the additive identity. Adding 0 to a number doesn't change it. But this simple fact is the key that unlocks all of algebra. It gives us a baseline, a point of equilibrium. It allows us to manipulate equations, to move terms from one side to the other, until we isolate the unknown variable, setting the whole thing equal to 0 to find the solution. Every single engineering problem we solve today starts with this principle.
But algebra was just the start. The next giant leap meant tackling an even bigger paradox. Think about it. An apple is falling from a tree. It's constantly accelerating. So how do you calculate its speed at one precise frozen moment in time? At that instant, the time that has passed is 0, and the distance it has traveled is also 0. You end up trying to divide 0 by 0, which is mathematically impossible. They hit a wall. The solution, developed by the brilliant minds of Isaac Newton and Gottfried Leibniz, was calculus. And the entire beautiful structure of calculus is built on this idea of a limit, studying what happens as a value gets infinitely close to 0 without ever quite getting there. They basically tamed the paradox by working with infinitesimals, these quantities that are almost nothing. Without a solid concept of 0 to approach, none of this would even be possible. And why does this matter? Oh, it only matters because calculus is literally the language of the universe. Without it, you can't describe motion or change or the laws of physics. That means no orbital mechanics for space travel, no fluid dynamics for designing airplanes, no electrical engineering, no modern finance. And that steam engine the Romans couldn't build? Optimizing it is pure calculus. The entire Industrial Revolution stands on the shoulders of 0. But the story doesn't stop there. Not even close. Now, we're going to see how this ancient, abstract idea became a physical reality, forming the absolute bedrock of our modern digital world. Because in a computer, 0 isn't just a theory, it's a physical thing. The magic of modern computing is all about binary, a system with just 2 digits, 1 and 0. Inside your phone, there are billions of microscopic switches called transistors. When a transistor has high voltage running through it, that represents a 1, the on state. When it has low voltage, it represents a 0, the off state. 0 isn't just an idea on a page anymore, it's a physical state of electricity. And the software running on that hardware is governed by Boolean logic, where 0 means false. And here, 0 has this special kind of power. Think of it like a veto. In an AND operation, both inputs need to be true, or 1 for the result to be 1. If even one of them is a 0, it doesn't matter what the other one is. The answer is always 0. It annihilates the operation, acting like a gate that lets a computer make incredibly complex decisions. You ever wonder why in so many programming languages you start counting from 0 instead of 1? It's not just some weird quirk to trip people up. It's because the computer hardware actually thinks that way. The index of an item in a list represents its distance, or its offset, from the starting memory address. So the very first item is at the starting address, which means its offset is 0. This direct translation from software to hardware made early computers way more efficient. And it's incredible, right? This same ancient idea is now literally powering our future. In the massive neural networks that drive modern AI, it turns out that most of the connections between the neurons have a weight of, or very close to, 0. They just don't contribute much. So by programming the AI to simply ignore all these zeros, a concept called sparsity, we can make these models run dramatically faster and use a tiny fraction of the memory. 0, acting as a placeholder for nothing important, is what makes the AI revolution computationally possible. So when you step back and look at it, this journey is just unbelievable. An idea that started as a philosophical threat, something so scary it was rejected for over 1,000 years, became the tool that unlocked algebra. It then became the key to understanding change through calculus, which fueled the industrial age. And finally, it became the physical language of our entire digital world. Zero really is the silent architect of modernity.
In the end, the story of zero proves one thing: an idea about nothing can change absolutely everything. And that makes you wonder, doesn't it? What other fundamental concepts might we be dismissing today simply because they seem paradoxical or represent a kind of nothing to us? What void are we currently afraid to look into?
Hey, thanks so much for watching. If you found this journey as fascinating as I did, please give this explainer a like and subscribe for more deep dives into the big ideas that shape our world.